Okay, welcome back. This is Mr. Hassan's Maths channel, and we have now question number 6 from the October-November 2015 Pure Mathematics Paper 1 from Cambridge. This is the 9709 syllabus. This is Paper 1 Variant 2, which also happens to be question number 10 from my end of topic worksheet for straight line graphs for my P1 collection. And this question here, we're told about points A, B, and C, which are given as A, -3,7, B, 5,1, and C, -1k, where k is a constant. We're told that AB is equal to BC, and we need to calculate the possible values of k, which is the y coordinate of C. So we can work out the length between A and B because they gave us the coordinates of A and B in complete form. And we know that the distance between B and C must be the same as A and B. So the first step here would be to find the length between A and B. Okay, and so what we're going to do is we're going to use a formula, which is the length formula, which is basically the difference between the two coordinates of the points, the x coordinates squared, plus the difference between the y coordinates between those 2 points squared, and then find the square root of that. This is basically an application of Pythagoras' theorem. So I'm just going to make a little sketch to make it clear how this is an application of Pythagoras' theorem. Just a quick sketch to just make that clear. So we have here our x and y axes and our origin. Now the point A is -3,7, so that would be, say, somewhere over here. Let's say this is -3, and let's say this is 7, so this would be the point A. And the point B is 5,1. So let's say that's the point somewhere over here, 5 and 1. Okay, let's say that's the point 5, 1. All right, and therefore that's the point B. So if I join those 2 points together with a straight line, okay, I'm trying to find the length of that line. That's what we're trying to find, the length between A and B, and that's the same as the length between B and C. All right, so now, in order to find that length, what we're going to do is we're going to apply this formula just to show you that this formula basically is an application of Pythagoras' theorem. If I find the difference between the x coordinates of A and B, that's going to be this here, and if I find the difference between the y coordinates of A and B, that's going to be that distance there, that will tell me the two shorter sides of this right angle triangle. This is like a right angle triangle here that we have. Okay, so we can see here the difference between the x coordinates is between 5 and -3, that's going to be 8 units. And the difference between the y coordinates is between 7 and 1, that's 6 units. So I can work out, as this is right angle, I can work out AB. So that's what this formula basically is. So when you do XA minus XB, all right, it's going to be the difference between these two, which is going to give you 8 units basically. So you're going to have -3 minus 5 squared. That's going to, when you square, it's going to be like 8 squared, which is 64. And then you have YA minus YB, which is going to be 7 minus 1, okay, 7 minus 1, which is going to give you 6 squared. So you end up with here, this is going to be the square root of 64 plus 36, which is the square root of 100, which is going to give you 10. So we can say the length of the line AB is going to be 10 units. Okay, so we know that from this. So now, therefore, we're told that the length of BC is also going to be 10 units because AB is equal to BC. So if I do the same thing for BC, if I find the length between B and C, okay, so we can say that it's going to be the square root of, now I'm not going to write the square root because I'm just going to write it as 10 squared, equals 10 squared. So I'll just write the whole thing equals 10 squared. I'll have to write the square root sign, just makes life a bit simpler. So 5 minus -1, so for B you're going to have 5 minus -1 squared, plus we're going to have 1 minus k squared is equal to 10 squared. Okay, and instead of writing the square root, I can just square both sides and leave it like this, easier. So 5 minus -1 is 6, that's 6 squared, which is 36, plus, I'm going to leave this in this form because it's easier for me to solve afterwards, but that's equal to 100. Now I could square this bracket and then I have a quadratic, bring in 100 to, subtract 100 from both sides, make it say equal 0, and then it's factorize and solve. But it's much easier because I have this square bracket to simply just subtract 36 from both sides. So you have 100 minus 36, which is 64, find the square root, and don't forget that there is, when we put the square root sign ourselves, there is a positive and negative possibility. So when I have 1 minus k, let me just get rid of the bracket, so I don't need the bracket now. 1 minus k is going to equal plus or minus the square root of 64, which means you're going to have 1 minus k is going to be plus or minus 8. So therefore we can say k is equal to, we can say minus 1, or we can make k positive, so you'll have 1 plus or minus 8. When you bring this to this side, it's going to be 1 plus or minus 8. So k is going to either be 9 or k is going to be negative 7. Those are the two possible values of k, all right, which we can find from this. So there we have the answer to question number 6 part 1. Now we're going to answer 6 part 2. So calculate, it says the perpendicular bisector of AB intersects the x-axis at D. So calculate the coordinates of D. So the perpendicular bisector, what does that mean? Let me just take this and bring it down here so we can just have a look at that. Let's put it over here. Okay, so the perpendicular bisector of AB. Well, the perpendicular bisector, okay, what does that mean? Well, the word perpendicular means at right angles. The word bisector means cuts in 2 equal halves. So the perpendicular bisector of AB will cut it exactly at its midpoint, exactly halfway between these two. So let me call that point M. And it will be a line which is perpendicular to the line, perpendicular to the line it's the perpendicular bisector to, so it's going to cut it exactly at 90 degrees through its midpoint. So this would be the line which is the perpendicular bisector of AB. It cuts it at right angles and it goes right through its center, halfway between A and B. So let's call this line L. Okay, so now to find the equation of a straight line, we need two things. We need the gradient of the line. So I need the gradient of the line. So I need the gradient of the line, which I'll call ML. And I need the midpoint, the point, I need any point on this line. Now the point on this line that we can find is the point M, which is the midpoint of, okay, AB. So midpoint of AB. That point is a point we can find on the line, all right? Because, you know, we know that the line passes through there. I know the coordinates of A, I know the coordinates of B, so I can find the midpoint of A and B. So how do I find the gradient of our line? Well, what we know is when two lines are perpendicular, so the gradient of line L is perpendicular to the gradient of line AB. We know that, so therefore we can say the gradient of line L times the gradient of AB has to equal -1. They are negative reciprocals of each other. Okay, so if I can find the gradient of line AB, which I can, then the gradient of line L would be its negative reciprocal. And if I can find the midpoint of AB, which I can, then I find a point on this line, and then I can find the equation of the line. So let's first of all, let's find the gradient of line L. The gradient of line L let's find the gradient of line AB first. So the gradient of AB is going to be the change in y over the change in x. So we can say 7 minus 1 over -3 minus 5. The change in y over the change in x. That's going to give you 6 over -8, which is going to be, if you divide by 2, you're going to have -3/4 basically. So the gradient of line AB is -3/4. So the gradient of our line, which I've called L, is going to be the negative reciprocal. So it's going to be +4/3. So you turn it upside down and change its sign. And the midpoint of AB is going to be the average of the x coordinates, which is -3 plus 5 divided by 2, and the average of the y coordinates, which is 7 plus 1 divided by 2. So the midpoint of AB is going to be -3 plus 5, which is 2, 2 divided by 2, which is 1, and 7 plus 1, which is 8 divided by 2, which is 4. So the midpoint of line AB is 1, 4. So now we have two things. We know the gradient of line L is 4/3, and the point on the line L that we know is 1, 4. So now we can use our equation y minus y1 equals m times x minus x1, and we can start to find the equation of this straight line. Okay, so to find the equation of the straight line using this method here, we'll have y minus y1, so y minus the y coordinate of the point, so it's y minus 4 equals m, which is 4 over 3 times x minus 1. All right, so we've kind of like, this is the equation of the straight line, not in any simplified form, but they didn't ask us to find the equation of the straight line formally. We need to find it in order to answer the question, because we know that the line L is going to hit the x-axis over here when y equals 0, because the x-axis is where y equals 0. So all I have to do now is replace the y with 0. You can say at the x-axis, y is equal to 0. So I don't actually have to write out the equation of the straight line in a formal way. I could just now replace the y with 0. If I replace the y with 0 at this point, I'm going to have negative 4 equals 4 over 3 times x minus 1. And what x is equal to when I solve this will be the point where it hits the x-axis. So we can multiply both sides by 3. We have negative 12 equals 4 times x minus 1. I can see negative 12 is divisible by 4, so I can divide by 4. I have negative 3 equals x minus 1. I can add 1 to both sides, so I can say x equals negative 3 plus 1, which is negative 2. So therefore we can say the coordinates of the point D, okay, which is a place where the perpendicular bisector intersects the x-axis, is going to be negative 2 and 0. Okay, so there's the answer to part 2 of our question, and that concludes this question. Question number 6 from the October-November 2015 paper, and question number 10 from my end of topic worksheet. Any other questions that you want to find from this paper that I have answered, you will find in the playlist that will be placed over here at the end of the video. Other questions from the end of topic worksheet from my P1 collection on straight line graphs, you can find other questions from that in this playlist over here. You can find also other questions in general on straight line graph that I've answered for AS level from the syllabus of Cambridge over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.